Greetings of the day. Myself, MSP Durgarao, Assistant Professor, Department of Computer Science and Engineering, MITS Madanapalli. In this session, I will be discussing about red-black trees. In this presentation, I'm going to discuss introduction to red-black trees, properties of red-black trees with example, and insertion operation along with the procedure of insertion operation, explanation with an example. Before going to this topic, actually, red black trees is related to data structures. Here, you need to understand what is a data structure. What is the use of data structures? So, a data structure is nothing but it is a specialized way of storing the data in a computer memory. That means, whatever it is the data we are going to store in a memory or a database, with the help of these data structures only we can store the data. In this regard, now I am in the topic of trees concept. A tree, it plays a vital role to store the large amount of data in a database. We have a tree is a non-linear data structure. We have a linear data structures and non-linear data structures. Now we are in non-linear data structures. A tree is a non-linear data structure is a way of representing the hierarchical nature of a structure in a graphical form. In this regard, three types of categories we have. One is binary tree, another one is binary search tree, and third one is balanced trees. So a binary tree is a tree. At most, in that tree, at most, a tree should consisting of two nodes that will be placed from left to right. That means every node should consisting of two nodes. Whereas coming to binary search tree, here we can compare. That means when compared to binary tree, in binary tree we can store any value in a binary tree in the format of left to right. There is no constraint in that binary trees. Whereas coming to binary search tree, we can store an element that element should compare with the root element. If the element is less than root element, we can store in left side. If the element is greater than root element, it store in right side. That is the concept of binary search tree. Now we are in balanced binary search trees. So balanced tree. Now we are going to balance the tree. Either it may be a height based balanced tree or a red black balanced tree or a splay tree or a B tree. We are having these type of categories. So here what we are going to do means balanced trees are a binary search trees. It follows a binary search tree property to insert or to delete whatever it may be we can follow the binary search tree pattern. So in this regard, a red black tree is a balanced binary search tree. Here we are using the binary search tree property to balance the tree with the help of red black tree concept. Here the color concept is there. A red black tree is a balanced binary search tree. We have already discussed that, which has the following properties. So every node either red or a black. So this red black tree consisting of some 6 properties. According to these 6 properties, we can do either deletion or a insertion or a deletion both. So coming to the properties of a red black tree, every node is either red or black. So whatever it is the node you are going to insert, that node should be red or black. The root node must be colored black. And every leaf, that means null node, must be colored black. If a node is red, then both its children are black. There should not be 2 consecutive red nodes. The meaning of that, we cannot insert a node 2 consecutive red nodes in the red black balanced tree. In all the parts of the tree, there should be same number of black color nodes. This will be considered after end of the insertion. We can check all the nodes, either 2 paths are equal black nodes are consisting or not. While doing insertion, we can check every simple path should consisting of equal number of black nodes. And moreover, one more important point here, every new node must be inserted with red color. These are the important points to insert a element or to delete element from the red black tree. based on these properties. Now, this is a example of red black tree. If you see the diagram, this red black tree satisfies all the properties of all the properties. So see there, this is a root node. Root node should consisting a red black tree should consisting of root node black. And one more point is every new node. See here, every new node. This is the last inserted node 9. So every new node should be red color. And one more property. So all the null nodes, these are the null nodes. All the null nodes of red black tree should be black color. And you consider every path. You just check the red black tree. You just check the red black tree. Every path should consisting of equal number of black nodes. So if you consider from root, that left subtree consisting of 3 black nodes and right subtree also consisting of 3 black nodes. So this is the perfect example of red black tree. The next one is we are going to insert an element. So before going to do insertion operation, so some conditions we need to know about. In a red black tree, we have seen already. In a red black tree, every new node must be inserted with the color red that we have seen in the properties. So in the insertion operation similar to the insertion operation in binary search tree, but that also I have mentioned before, because it follows the BST property. So only one thing here you have to think about, that is it follows a color property. That's it. After every insertion operation, we need to check all the properties of red black trees that you need to remember. If all the properties are satisfied, then we go to the next operation. Otherwise, we perform the following operation to make it as red black tree, because red black tree is a balanced binary search tree. Here we are balancing this tree with the help of color code. If tree is not balanced, what we have to do? If it is balanced, means the tree satisfies all the conditions of a red black tree. If it is not, means what we have to do means we have to balance it. How we can balance it? With the help of recolor, rotation followed by recolor. These are the 3 conditions we have to do. We have to perform while balancing the tree. Now coming to insertion algorithm. So we have up to that we have seen some steps related to insertion. Now procedure, how we can actually start the procedure to insert an element in red black tree. So it follows a certain procedure. You people know about the algorithm. So algorithm is nothing but a step-by-step process. So in step 1, first we have to check whether the tree is empty or not. So if it is empty, then add new node as a black color. Because in red black tree, every new node should be inserted as a red color. But if the tree is empty, we just insert a color as black color, because that node should be a root node of that entire tree. So root should be black color. And the step 2, if tree is non-empty, add new node as red color. So if it is not non-empty, means we are inserting element is a new node. So new node color is red color. If parent of new node is black color, then end the process. The parent of the new node is black color, no need to do any operation. We can go with next procedure. Else, if it is not, the parent of new node color is red color, that means not black color, then we need to perform some operations. If it is black color, then rotate and recolor. If it is red color, means 2 consecutive red nodes will come. So at that time, what we have to do? Recolor and check, grandparent is root or not. If the grandparent is root, then recolor and recheck. I hope you people understand the 4th step. And coming to the step 5, if parent have no sibling, then rotate and recolor. These are the steps we can follow. Now coming to the example. This is a real-time example. I'm going to explain with an example to insert elements in a red black tree. So here we are taking some elements to perform a insertion operation in red black tree. So first of all, in that set of elements, the first element is 8. So tree is empty. If tree is empty, the node should be black color, right? So 8 should be black color. And coming to next element is 18. The tree is not empty because the tree is consisting of one element, that is 8. So we can insert that new element in the new element with the color of red color. But before that, we should compare with the root element. If the new element is less than root or greater than root, because here we are following BST property. So 18 is greater than 8. So we can place 18 at left side of 8, right side of 8 with the color of red color. The next element, 5. So now we are going to insert 5. 5, this is new element with the color of red, but we can compare with the root element. So 5 compare with 8. 5 is less than 8. So we can place at left side of 8. That means root side, left side of root. And coming to the next element is 15. So 15 is new element. We can able to insert 15 with the help of red color. When compared to root, BST property, so 15 is greater than 8. So we can place at right side. Again, right side, one more element is there, that is 18. So 18. So when compared to 18, 15 is less than 18. So we can place at left side of 18. So now problem came. Coming to, compare with the properties of red black tree, no consecutive red nodes should be there. So for that, what we have to do? There we have mentioned the condition also. Here there are two consecutive red nodes, 18 and 15. The new node's parent sibling. The new node. Which one is new node here? 15 is the new node. New node parent is 18. New node parent is 18. Parent sibling. New node parent sibling is 5. Parent sibling is 5. So new node's parent sibling color is red. And parent's parent is root. Parent is 18. Parent's parent is root 8. Parent's root is 8. That means the parent's parent is root. So we use recolor to make it red black tree. Here what we have to perform means, what we have seen here, the new node is 15. 15's new node's parent is red color, and parent sibling is red color, and parent's parent is root. Parent's parent is root. Then what we have to perform here means, so we use recolor to make it red black tree. Here we have to balance the tree with the help of recolor operation. So after recolor, what will be happen? See here. After recolor, so 5 and 18 should be changed, color changed. Here we performed the color change. After recolor, 5 and 18 black color and 15 red color. So now tree is satisfied. If you compare all the property, if you consider all the properties, this red black tree satisfies. Now we are going to insert a new element, that is 17. So 17 is new element. Again same property. According to BST principle, we are going to insert 17 is satisfied. That means greater than 8 and greater than 15. So it is satisfied right side of 15. So with the help of red color, again same problem came, that is two consecutive red nodes should not be there in red black tree. Then what we have to do? So we can check with the parent. So the new node is 17. New node is 17. New node parent is 15. Both red color. New node's parent sibling is null. New node parent sibling is null. So we need to perform some rotation here. So which rotation this is? We have to consider which rotation this is. I hope you understand. New node is 17. New node parent is 15. So if new node parent is not having sibling, at that time we can perform the rotation. This is LR rotation. This is LR rotation. From 18, 15 is left side, and from 15, 17 is right side. This is LR rotation. If this type of rotation came means, what we have to perform means, we can perform first right rotation, then left rotation. This is left and this is right. So first we can perform right rotation, then left rotation. After left rotation means we are performing right rotation. That means left rotation, it towards go to right side. Right side. That means the 15 came up, sorry, 17 came up and 15 came down. So after applying the right rotation and recolor, right rotation in the sense left side it will move. So left rotation. So 17 be the root and 15 and 18. So here color change, color, I mean recolor also performed. That is 17 is color 17 is changed. The color is black. So now the tree is satisfied every property of a red black tree. Now insert a 25 next element. So next element 25 is a new element. So we are going to insert a new element in red black tree. That should be in a red color. So 25 in a red color. 25 red color. So here again problem came, two consecutive red nodes should not be there in red black tree. So for that what we have to do, we can check the condition. Here there are two consecutive red nodes, 18 and 25. If you see 18 and 25 both are consecutive red nodes. The new node's parent is 18. Parent sibling color is red. 18 sibling is 15, color is red. And parent's parent is not root node. Parent is 18, new node parent is 18, parent 17 is not a root node. Then what we have to do means, so we use recolor and recheck. First we use recolor and recheck. So we can simply change the color of 18 and 15 to red to black, then tree satisfies. After changing the color, what will be happen? After recolor operation, the tree is satisfying all the red black tree properties. So then we can proceed with the next element. So tree is not empty. So now we are going to insert element as 40. New element 40. So that 40, it satisfied when compared to root node 8, it satisfied right side of the 25, because 40 is greater than 25. So again problem came, that is two consecutive nodes 40 and 25 both are red color. So at that time we have to check the what rotation we have to apply. So the new node's new node parent is 25, sibling is null. So we need a rotation. If sibling is null means we can perform a rotation. That is which rotation? Here we use LL rotation. If you see from three nodes, you can consider from three nodes, new node parent, parent's parent. That means grandparent. So 18 is the grandparent of 40. 25 is the parent of 40. So we can consider from 18, that is LL rotation. LL rotation and recheck. That is LL rotation in the sense, actually that is RR rotation. RR rotation, we can, we are considering is LL means that that rotation towards move to left side. That means 25 be the root, 18 is the left side of 25 and 40 is the right child of 25. So it moves towards left side. So for that case, we can mention LL rotation and recolor. So after LL rotation and recolor operation, the tree is satisfying all the red black tree properties. So what are the 6 properties we have discussed before? That all 6 properties satisfied by this tree. Right. Now, next element 80. So we are going to insert, next element is 80. So new element, definitely this is new element. So that 80 we can compare with the root element 8. So 80 is greater than 8. Then we can place the 80 at right side of a tree. So in right side, all the elements less than 80. So we can place right side of the last element. That means 40 is the last element. So we can place right side of the 40. So even after inserting, again problem came, that is 40 and 80 both are consecutive elements with red color. It should not be there. So at that time what we have to do, we can compare with the tree. So first what we have to compare means the new node's parent. The new node's parent color is red. Also parent sibling color is red. And parent's parent is not a root node. Here parent's parent is not a root node. So what we have to do means we have to perform recolor operation, we simply change the color of 18 and 40. We simply change the color of 18 and 40. See, after changing the 18 and 40, what will be happen? So after recolor operation, tree again two consecutive red nodes came. After recolor, two consecutive red nodes came, that's 17 and 25. So again problem came. So here what we have to do, you check the new node's parent. New node is 80. New node's parent sibling color is black. Now new node's parent is 80, parent is 40. 40 sibling color is black, 18. So we need rotation. We have to perform rotation. Which rotation we can perform? We can consider from the three nodes. So seven problem occur at 25 and 17. So 25, 17 and 8. So 25 is the node. So 25's parent is 17. 17 parents is 8. We can compare this. That is which rotation? That is again that is the normally right RR rotation. Here we can this RR rotation will move towards left rotation. So we are performing left rotation here. So after performing the left rotation, that 8 moves towards right left side, 17 also moves towards right left side. So 17 be the root, 8 8 is the left child of 17, and 25 is the right child of 17. So after performing this rotation, the final tree satisfies all the conditions of red black tree. If you check once, the root node 17. Now the root node is 17. 17. The root node should be black color. It satisfies the first condition, and the second condition, no consecutive red nodes. No consecutive red nodes in a tree. There are no consecutive red nodes. So second condition also satisfies, and the third condition we have every new node in a red color, that is 80 is the last inserted node, that should be red color, that also satisfied. And one more point, after all insertions we have to check if in every path should consisting of equal number of black nodes. If you see, if you check in every simple path also, or if you check left path or right path also, it's satisfied. So from root to left side, 17, 5 and 15, these three are the black elements, so black nodes. And coming to the right side, 17, 18, 40 also black nodes, equal number of, this side also three elements, this side also three elements. So finally the tree satisfies all the conditions of red black tree. So this is the perfect red black tree. So here I have given the link for reference. This is the reference link for red black trees. Thank you.